Yeah, I really like this. So, going to here. Hello. Good evening. It is the night time. So there is a few things that like as I was fading out of consciousness, well, I feel like I should uninstall it. There's maybe watch on this machine. So. There's something I can do. Yeah, let's say. Let's say you have your so if you have your if you round the hit location to the nearest corner, you know for a fact that exists somewhere in you, right? You know this. You know this to be true, right? Now, regardless of what happens, there are two different scenarios. But no matter what happens, only two scenarios that actually matter for when you have a situation. If these two oh, interesting. If I do that. Ooh. Well, so either when you have this, right? If at any point, right, you have a hit, it could be on this side, it could be on this side, it can be on this side, it could be on this side. You have something like this, right? You could have one here, but also you could be missing one. Now, there's a very interesting variance, and that is that at one of the diagonals, either these two that are diagonal from each other, or these two that are diagonal from each other, are the same, are in this corner. Then you know that you have a corner condition, and that you should evaluate that as a corner. Yes. So And I can show this, because what if we make that false? What happens here? This is an assumption. Now we test the assumption for when it is false, and if it still holds true. Here, we know for a fact that at least one of them needs to be solid, otherwise you have no point. So we can assert that there is at least a minimum of one tile colored in, one tile taken out. If that is the case, and neither diagonal is the same, right? This is the only configuration where that is true. Also, this is the other configuration where that is true. But in either case, it's only two and they are adjacent from one another, right? And the other two are empty. We are asserting that this situation should evaluate into false. Should evaluate into false, correct? Because here, this is not a corner. This does not look like a corner. Also, this is a corner, right? Because we're only looking at here. This must be a corner. Because there's nothing along this side, there's nothing along this side. This is an outside corner, this is a corner, evaluated as a corner. What happens if we have this scenario? Oh, well, is this also a corner? Because these two are diagonal. Well, this is also a corner. Because we have a corner here. What if this? This is another edge case. But we would also want to evaluate this as a corner, because technically speaking, we have two outside corners. So the only thing that matters is if one diagonal contains the same elements, the same value in both squares along the diagonal. Right? So as long as we can detect that, it's fine. So how do we do that? How do we want to do that? Right? How do we want to evaluate? This is just the main. We'll have a code 208. Oh, hello. Hello, Arthur. How is the skunker today? Now, I'm going to also change the appearance and bump that up a little. I said bump that up a little. Ooh, okay, that's fine. I don't think you've seen what all that I've got going on. So let me show you what all we have for you. We have this. Yeah. Fixed a bunch of things with my trackpad being stupid, fixed a bunch of things with other stuff. Yeah, I have the distance fog. I'm not happy with the distance fog calculations, but the existence is there. Also, this is taking in a tile map from a texture. I have full collision. I can't run into walls. I can't do any of that. These bricks are not a texture. There's only one texture, and that's the actual map itself. So none of this is textures. So the next thing that I want to do is I want to find out what conditions make up for these corners, right? Corner detection. Because I don't like how, like, if you see here, like these corners don't look very good, right? Because these short bricks are like halved, but that's not very solid, right? The short bricks are halved, but it's not what we want. We want to have an edge indicating a corner along these, right? So that's what I'm figuring out now. And that is going to be fairly straightforward to do. We have to get color. We have the equals colors planes, and then so the wall texture, right? Here's where things get a little wonky, right? Because we have the plane, we have the UVT, but we don't have. We also have the cell. Alright, we have the cell, but we don't have whether or not it's a corner. And the only other time that we have a corner that isn't a thing is if all four of them are the same, right? So we have the hit location. Okay. We have the hit location. We round the XY to the nearest corner. We check all four of those corners. Oh, holy fuck. Interesting, because we could also do this for the floor. Oh, this is going to get so much cooler. So we have the cell. We have the UVT. We can make test equals UVT. Oh. Yeah. Because we can have this, right? We can have this again. So these are the UVTs. Right, this is the information that we're actually sending to that we're sending to the color fetcher, right? So this is how all that works, right? Is it a bit of an eyesore? Yes, it is. It's a bit of a vapor wavy goodness. We can do that. If we really wanted to, we could do a lot of things, right? Because we could, yeah. But that is the information that we are setting in. We know. There's that, right? So we can also so after here, what we could do is we could also pass in corner or not corner. We could pass in is corner. And then from there, we can and we can apply a bunch of other, logic and stuff. So if we are going to do that, then one of the things that we can do is, oh, holy shit. Especially with the way that I want to handle the floors at some point. This is fucking perfect. This is so good. I just solved a huge thing. Oh, this is gonna be so good. Oh, this is gonna be so fucking good. This is gonna be incredible. Yeah, the bricks. The bricks is literally like way better than equals colors plane, and then I can make it so that so let's say in bool is corner, right? I don't know if I want to pass in the distance to the corner, or if it is a corner. Right. Because I can do something along the lines of, like, say, from the nearest corner, I could say, D corner, right? D corner. Or two corner, right? Two corner, and this is float. Right. And like that's fine, right? Because then what I can do is I can say, colors is equal to that. So I could also change like the floors and I think for now I'm just going to say the minimum of that and return call. I think for now I can do that. So yeah, and this is the get goal. And then for now, I will say floats to corner is equal to the minimum the absolute value of UVT dot x 5 value of UVT dot y 5 and this should be fuck. Cool. Yeah. So that is correct. Oh, this is not correct. This is the inverse slope. So, yeah, I mean, this looks really cool. And there's a lot of really cool things you can do about it. Right? This makes everything look all sliced out and stuff, right? It looks like there's like slices cut. Which is really cool. Right? So we want the actual distance from the corners to do it. Not this nonsense, right? So. Right. There we go. So now we have these. And then we have more harsh slices, like this. Yeah, because it's all from the corner, right? This is all from the corner. So we should be seeing that. Something like that. Right. So I think that is correct. I think this is what you'd expect. I mean, at least up on the walls it is, but not here. What is going on? So why is that not? Call it the minimum of the time to form the... Oh, I know why. Okay, so it is working properly. Because doing even in here, it's fine. Because money. It's not what I expect. Hold on. We are... Oh, wait, yeah, okay, yeah, okay, yeah. Okay, yeah. Instead of from the edge, it'll be from... Oh, no, oh. From the corner. What I actually want is to have a different, because like what from the corner means is a little bit different depending on, so what from the corner means is a little bit different, because here, it means So it should be. So from here, we want it from this edge. We want it from the edge. We want it from the edge. Right. We want to test it from the edge. It's not actually from the corner, it's from the edge. The problem is that these are on the edge, right? Because we're also like saying like, hey, are you like from? Okay. So what is it? I'm doing wrong. So the two corner. Yeah, that's what I thought. So this is what we actually want to see. This is what we want to see. But we don't want to see that on there. Okay. So this is actually going to, again, take a little bit of oh, hold on. So we could do this again. Right. So we take the current location, we subtract so we want to find out how far away it is from the nearest corner, from the nearest edge. Right. Since we take a UVT, right? And 3 see, and then it's right. So T 0 okay. Right. So then what do? We know that we've hit something. We also have information about the yeah, we also have the information about the cell height, all this other information, all this other stuff, right? So that's fine. So what is it that we do? We do So what we do is we say in the int plane, we have the UVG. I could say so it'll be the float distances yeah. The first distance is the one that is hitting along the x-axis. So we ignore the x-axis entirely. And we just say the minimum distance between well, we could do let's do actually D's. Let's do that 3 D's minimum of the UVQ shit. Oh, hold on. So D-min and D-max, right? So we can do the minimum of right. So you do the minimum of D and sizes minus D. And sizes minus D. So it is the minimum of UVT and the sizes in its size. Cell height. Where the fuck was I? Okay. And cell height. Right. We do that. The D's. Yeah. Then what do we do? Well, we know this, right? Then all that we then have to do is just multiply it by whether or not it is actually a Boolean, right? Whether or not it's actually true. How do we do that? Well, first let's actually calculate the distance. So, one, GC 3 So, here's the first one. So, the first part. So, the first part is going to be the minimum of dy dz, right? The minimum of dy d's dot y d's dot z, the minimum d's dot x d's dot z, minimum of d's dot holy shit. ds is equal to ds is equal to minimum of ds dot along the x plane dot yz dot yzx is equal to z x y. A little bit of magic hacker. Swizzle magic. So with this swizzle magic, we just return t is equal to ds. Yeah. Okay, it's just plus 1 minus 1. So we just figure out whatever it is, and then you just, yeah, we take the minimum distance between the minimum and the maximum. And we take the minimum of not itself, which is +1 -1, and we just index into that. This bam boom about 0. Okay. And then everything else should be the same. Yeah. Because 2 corner is equal to get corner. Float 2 corner equals catch distance. It is the UVT and then the time. Holy fucking shit, dog. This shit immediately works. Okay, cool, perfect. Now this is all based off of path. And then the actual bit is that we can multiply by fuck ton, and then multiply by like 32 or some shit, right? So all these are the individual cells, and then we multiply it by if it is if either of the corners, if either of the diagonals are both the same thing, but not all the same, then do the corner stuff. Then evaluate the corners. Because we only care about the tile for tile shit, right? So, technically speaking, right, we don't really care about that. Now what we can do is we can also evaluate on the vertical or horizontal. Right? So we could always match the so it's the XY plane. Everything within the XY plane needs to be handled. So how and in what way do we do that? So how do we do that? We can do, because I might have made this harder on myself, right? But it is a lot more, but this is a whole hell of a lot more flexible. Right? This is a lot more flexible. Or at least it's a lot more robust, right? It's a lot more generic. It's less specified. It's less specialized, I should say. Because the less you specialize, the better. Right? That means you can make changes very easily, it's very generic. Like the more generic you make things, the better it becomes. Right? Because you're not making a game, you're writing a framework. Right? So Okay. So this is the wall texture. And this is the distance to the corner. So we know for a fact that that comes in with the right. So one way to do this is that we can because this is just like the color, right? This is just the edge distance. Because we will wait. I mean, we could say we add if yeah. So we could like add one. Right? So how do we eliminate? Well, we can do, well, I mean, this is the actual distance, right? This is the distance to the edge. Right? This is the edge distance. So what we want to do is we can say on the XY plane, we just because I would want to create like an edge mask, right? So the XY portion of it. Oh. Fuck. I mean, see, the problem is so the problem is here, right? Oh. But could be somewhere over here, right? Because if this is occupied, take a look at, this corner here. And it hits over here. If there is a match here, these two are connected. And from here, it is either going to be okay. So one of the things that I could do, because I like that gradient thing. So it should be on like a corner to corner basis, right? So from, if I hit the XY plane, I think is going to be easy, but same logic for, so all I need to do is just detect if it is a, is corner, right? Is just flag is corner. That's all I need to do. I just need to find out if it is a corner. I just need to do the logic to do is corner. And then I can mask it. So I can say, or yeah, is not corner. Is not corner. Bool is corner. I mean, I could just invert it, right? It'd be easier if I just detect if it is a corner, because it's if one diagonal is a thing, if the other diagonal is a thing, if one diagonal is a thing, or if another diagonal is a thing, and all of them are not the same. Yeah. So bool is corner. So I need to have the UVT. Right. I need to have the in vec2 cell in vec3 VT. Correct? Yeah, I-vec2 is a cell. So is an I-vec2. So B corn is equal to return B corn so if so the first step is to find out so we do a floor. cell plus UVT, right? Cell plus UVT. Oh shit. How do we handle the vertical one? Fuck. Oh, and that's not true. That's a little bit off. Shit. I think I need to inject his corner into the get edge distance. Because I need to, when I'm calculating the distances in each of the in each of the directions, I get edge just. Right. Am I doing anything here? Yeah, okay. Because I'm getting the distance to the nearest valid edge. Right. So we have get edge distance in plane, and I vector cell. Right. So let's pass cell in. Yo. Okay. Yeah, so we have that. Now what we want to do is between here this is where we do the magic. This is literally the magic. Right here. So this is all good and dandy right here. But all that we really need to do is just figure out if we're on a corner or not, right? And if we are, then we can just add 1 to the distance on x and y. Right? ds.xy plus equals 1. And it's fuck. Right? Yeah. So here we need to detect if we are on a corner or not. Yeah. Mm-hmm. Plus equals that plus equals 4, I think, something like that. Um, okay, so is fill. What is it? It's we have the in project to so what is how is this gonna work, right? Because the main thing is that we want the if it's inside of the middle, then it's 1. Otherwise, if it's inside the middle, oh well, yeah, because in the doesn't matter. All that we're doing is just checking to see if it is indeed a if we have a did we do or not? Because what we'll do is we'll do a maximum of is fill in the distance, right? And then that'll be fine. And then we can just multiply the distances by 2. Yeah, we just do dist, yeah, the ds times 2, and then we do a, and then the xy is equal to the maximum between 1 and xy times 2, right? We multiply the whole thing by 2, and then we do xy times 2, yada yada yada. Yes. Alright. So with that in mind, that being said, yeah, we're just doing is fill 1. Because then what we can do is we can do a maximum of that, and then max of the is fill, yeah, blah blah blah. Right. Because that'll make the gradients match up nicely. So we don't have any discontinuity. Yeah, and it'll work quite well. So oh shit. Okay, well that's not what we want. Okay. So yeah. So here. If it is a thing. And if well we could do human so Minsa. I'll get to Minsa is equal to the 4. For 5x2 of the 4 of the x2 5 plus e2 dot x minus 0.5. That is the starter. It doesn't matter what it is. If it is in the upper right hand corner, then it just stays in the same thing. Right. And just gets floored. Yeah. So that is the starter. And then we go up by 1. So we say if we could do a so what we want to say what is the conditions that both diagonals are different. It is a fill if both diagonals are different. And well, for one, we check to see if all 4 of them are the same. Right? All 4 of them are the same, or both diagonals are distinct, right? Or that both diagonals are distinct, then it is a fill. It's a fill, right? It is a fill corner. So what is it? If it gets so. So roll I fill is equal to why does that get so too? Oh, that's right. Okay. And get some min cell is equal to alright. And if the sum is 0 or 4. If actually, so is it returning? How does it return? Return an int, get cell int. Okay. Okay. Int d1 is equal to get cell in cell plus get cell plus I vec plus 1. Hmm. Wait. If they are the same, because all that we really care about is whether or not D1 equals D2. Oh, wait, no, but we do care about whether or not they are all the same. We do want to add. But we can, if they are all the same, alright, either oh, okay, so we return true if like if I add, because if they are different, right, we want them to be different, right? Then that means both of those is a fill if it is equal to 1. Right? Okay, well, I'm just gonna do plus I web to 0 plus cell min cell plus I web to 1. So what is the conditions? So bool fill is equal to, if they're all the same, if all of them are the same. Wait, if one diagonal, if both of those are 1, then that's a 1 and a 1. Cool. Then that means that equals a 2. And I subtract that from the second diagonal, which if they are all the same will also equal 2, which means I get 0. If all of them are 0, then because if they are the same type, the sum must be the same. So all I need to do is just return if D1 equals D2. Because either both of them are 0, so D1, they are both 0. meaning that they are all, meaning that all of them must be 0. Okay, which means D2, both of them are also 0. D1, one of them is 0, one of them is 1. That means they cannot all be the same. And that also means that D2 must also not be the same, meaning D2 must also add to 0, must add to 1, which means D1 and D2 must add to 1. Second and third condition, the diagonal is 1 and 1, meaning that they add to 2. And since they are diagonal, and we want it to be a fill, that means all 4 of them must be 1, which means the other diagonal must also be 2. Meaning that as long as the diagonals are, the sum of the diagonals are the same, we have a fill. That is fucking incredible. It's literally 4 lines of code. Ha! So then when we get the edge distance, we have is fill. If it is a fill, we get the maximum between that bit and the edge pieces, which is one, which is that and is fill, which we interpret as a flip. This is going to be equal to the maximum of this, comma, is fill, so UVT. This should just work, honestly. No. So close. Oh wait, no, that is correct. Except that is correct on that side, but not on the. I mean, we got those. So don't have that. But we also need boundary. We need bound. Okay, so this is all pointers. Now that is just the logic for the XY portion. Yeah, the XY portion is that. The Z portion. I mean, and this is also like kind of not entirely accurate, right? So if we hit along the X or the Y, we want to make sure that Fuck. Okay, we're getting closer. We are properly detecting all corners. So, okay, I see what I'm doing. This part is wrong. So that part is wrong. I need to be putting it in here. For one, I need to also be multiplying this by 2. Yep. So that becomes a 1 right smack dab in the middle, which is what we want to be seeing. This is correct. Then all that we really need, which is so fucking cool. Oh, I'm so stoked. I'm very excited. Because that is like literally cutting it in, right? Because then we can also like raise and lower the max, right? Because we do want to create a mask. Because that is happening. Monday? Yeah. Yeah. Because that's happening. In the color. In the color. Here. It's happening here, right? Because we could do times 60. Right. There we go. Right, so now we have these cuts along there, along there, along there. I mean, this looks fine. Alright, like this looks fine. It's fine. It's not, but it's fine. Right. You know, we just have these cuts here, like on these sides here. Basically going in with a router and putting into everything, right? That's kind of what, right? This is the overall effect of it, but only on the edges. Because then we can do the floors and the ceilings to be two completely separate things, and it's going to be so. We have the ISTO. All that we need to do is detect. So we have the DS. What is Is it the because because I'm not so sure that I'm understanding everything actually properly, right? Oh, because I'm not. Think about think about this condition. Think about this situation here, right? And our hit points. Let's see. How should this look? What we want is that. Oh, but our hit is here. So what happens if it's here, and what happens if it's here? Right. These are the three conditions. So first we find out if oh, I guess if we would want to. So we want to find out if we are at a, and then if we are doing, so I think the wall side, the wall part is going to be the easier side. The easier than the, let's deal with the walls first. The walls are going to be easier first. So, right, ds dot xy is equal to the minimum. Well, is going to be equal to max. Yeah, the maximum of float is fill. I is style UT. And let's find out what that's like. Fine. Okay. Okay. That's getting us literally the same. Did that literally just do the walls just fucking outright? Yeah, it did. Interesting. So it did the walls literally outright. That's cool. That's good. so the wall detection is done. Now, all that we need to do is have proper, is the proper this detection. Why is that? Let's fill. Let's fill. Interesting. So DS max is going to equal. So the maximum so there are two things that we want to find out. Okay. So because of the swizzle, because of the swizzle sticks, the swizzling. Because of the swizzle swazzle, things are getting weird. It works perfectly fine for the XY. It is really, really cool. I'm super thrilled. I'm super stoked. Right. Because once I get this done, it's all gonna blend in. Like perfectly. It's all gonna blend in perfectly. Yeah. It's all gonna blend in. Because I also need to detect this. So what is the edge? Oh, right. Because all I need to do is detect like neighbors. And the way that I do that is I find which side am I closest to. And there's like, I need to handle So let's do... So for one, I just kind of assume, right? So I can find out if I'm in a corner. If I am out of a corner, that means fly. So I know for a fact that I'm going to just get my distance from the edge. That is working as intended. Perfectly fine. Then what I need to do is that if I'm hitting the floor, right? So if I'm in the here, so I find out which one I'm in, right? Because like this cell. Well, I just do the minimum. Plus... No. Nande. Nande. Oh, I just do the... So if I want to find out what... Oh, no, I know what cell. And then I just do the min cell. Yeah, I just do cell minus min cell. Oh, no, I do min cell minus cell. Right. I do min cell minus cell. Because then all that I need to do is just say, hey, I need to... Wait, what's... I'm getting the minimum of it. Duh. Fuck. What is that minimum? Which is that minimum? That minimum is kind of fucking shit up. So how do I make it not fuck shit up? Alright. So how do we make it so that if it's, you know, hitting before? After? Do I do it after? So I might be able to do it after, right? I might be able to do... I might be able to do some shenanigans after. Because one of the things that I could do... Yes, stop. Because then what I could do... Because I want it to be smooth, right? So from the middle out to the edge. From the middle out to the edge. I can just add stuff to it. So all that I need to do is figure out which one I'm in. Right? Because technically speaking, I don't need fuck. Fuck. Okay. So, what's happening here? So here, why is this one going to have, it's not draw shift. So this one is going to have this one. So why? Right? So if it is on here, we can just Okay. Which also means that all we need to do is we just need to find out for a given point, we need to find out its distance to the nearest wall in both directions. So, how do we find out the distance of the wall? And it's also going to be max. Max X, max Y. It's going to be the maximum between the two. So, how does that work? Let's say we have this, right? We know that we're in here. We know that we're in here. So say if this one is full, this one is full, we're in here. That means that we need to check, because it would be better to be able to, because like how do we find out the difference, right? Because if it's above us, then it's if it's above us, so how do we find out what what side we're on. I don't think it actually matters. Right? Because so the left is just a sum. Right? The left side is just this plus that. Cap that 1. Right? Yeah, this plus that. This plus that. Okay, what if we can just say the x is well, if we say the x distance is so we want the maximum. So the maximum of max of this plus this times 0, 0 plus 0, 1 times x 1, 0, 1, 1 times 1 minus x. That should be dx flat. Right. Because basically what ends up happening is, like, and we're also playing this, right? The minimum of 1 and this sum times x. And the minimum of 1 in this sum times 1 minus x, right? And like, why is it like such a huge deal? Like, why is it such a big thing? So okay. So let's take a look, right? Let's take a look. let's take a look. It's in a book. It's reading Rainbow. So we get edge dist. Fuck. We fuck. So what we want to do. Well, so in either two because we're doing this stuff, right? Technically speaking, you could also do some stuff with this. There's a lot of stuff in there that I don't actually give a shit about. Right? The isfill is very cheap. I don't care. A lot of this stuff is like super cheap. I'm sure there's ways of optimizing this to make it a lot faster, more performant, yada yada yada, if it actually matters, but since it doesn't matter, it doesn't fucking matter. Alright? So I don't care enough about that. Right. So in here, so I back to in cell. So we have the dx should be the maximum of that stuff up there. The maximum of get cell of min cell of the min of 1.0 and get cell min cell cell and cell 201 times uvt.x. Oh wait, hold on. So I should do left, right, up, down. Float left is equal to times 1 minus x. left is equal to the distance to the ones to the left is equal to. So if they are on the left, okay, so if it is on the left, then we do the minimum of 1.0 and the sum of get cell at min cell plus get cell min cell plus I vec 2 0 1 times UVT dot x quote, right? Because it's actually going to be the minimum of these. It's going to be the minimum of the left and the right versus the maximum, the minimum of the left and the right versus it's the maximum of the minimum of the left versus right and the minimum of the up versus down. No. Maximum. Maximum. It's going to be the maximum of all of it. Because if both of those are 0, then it's going to be 0. And we just fucking ignore it. But so if I am in there, then I'm going to be over a half. And then I'm going to if that is a thing, then I actually do minus is this way. Then we can do the minimum of the left versus the right. And then we could do the maximum of the x versus y. Okay. The minimum of the left versus right, maximum of the x versus 1.0 minus the minimum of 1.0, comma, xl. The min cell plus 5f2 1 comma 0. Actually I should do 2 0. one. Not quite. Yeah. I'm sure there is a much nicer way of handling all this, but work ugly than work. So I'm not going to be worried too terribly much about the aesthetics and how cleanly and how elegant it is yet. I'm sure that there is a way to do it very, very plainly, you know. It's simply just because, right? Because there's just like a lot of stuff in it that are things. I feel like I should just do a whole explanation of a lot of this stuff, but I probably will at some point. I don't really care. I could create a lot of content out of just current, to be honest with you, because there's a lot of things involved that are pretty fucking bonkers, honestly. Because there's like and then I wrap all that up in a but that's gonna ruin the corner, the outside corner. It's gonna ruin the outside corner. Wait, the outside corner versus inside corner. Nande. Because there's something very interesting. So, if this is it, if this is the tile that's occupied, then when we're looking at here, we know that it should be one here, always one here. And it should go to 0 here. From Hold on. It's just a linear interpolation. From 1 to 0. 1 to 0. From 1 to 0. But it's 0. 20 is the maximum in this direction. But in here, I think this is the minimum. Or it's still maximum. Because if we take a look at in this case, is 1, 0, 0, 0, right? We know for a fact that those are all going to be 1 and we know that's going to be 1 here. It's 1, 1, 1. So that complicates things. Because there's 2 different sets. Because it does change. Okay. I think no matter what, e dot xy 1.0 minus evt dot xy. So we have those 2. So it's always going to be that. So it depends on whether or not it's going to be the minimum or the maximum. Right. It also depends on whether or not it's going to be only one or the other. Because like one of the things that I could do is I can say, hey, because like um you can instead of checking every single cell in the neighbor, it's just better to do like a 2 by 2 and just do on a corner by corner basis. Because if you handle them by the corners, then because if you handle them by the corners, then it's just more awkward. So we want to be able to say um hmm. Ah, I think there's a way that I can handle these, right? I think there's a way I can handle these. Because if it's fuck. No. Okay, okay, okay. Yes, I do actually know that there's a way that I can handle this. So. I build an array. Build an array of each of these, right? And it also doesn't matter if I do it in a for loop or not, because the for loops literally just get unrolled at the compiler level. Right, so it doesn't matter if I unroll them or if the compiler unrolls them. It's the same shit. So the big difference here is that I have I want to have 4 separate ones. A left, a right, a top, and a bottom. Right? So Right, and the reason for that is because I'm looking at the 4 different sides, right? So float top is equal to 1.0 minus that one. Float top is equal to ubt dot y. Float left is equal to ubt dot rt 1.0 minus ubt dot x. Okay. So what happens here? That is the minimum of right. No. That should be the maximum of, so float 0, 0. C 0, 0 is equal to the maximum of bot LT float C 1, 0 equal to max of bot HE float C 0, 1 equal to stop. Float C1 equal to max top IT and then yeah, we have the maximum of all of those. Right? And then I think I just do minimum on everything. Yeah, I think if I just do min. Okay, I don't know. But only if it exists. Otherwise. Um... If it is, then what do I do? So I should be able to multiply all of them by 2. And then cut them off at 1. And then have all of those. Good. Now, I do a float. Now I should be doing what? The minimums of always? Right? I think. Ow! But Monday. I don't know. I'll just have to think about it. Hello, Cork. Cork, how are you today? this evening. Welcome in. Welcome in. How has your day been? How has your night been? I'm doing okay. Just figuring out how to solve a little bit of an issue here. Do I actually have wall distance anywhere? I do not. Well, I guess I could just say just chilling. There's your small server. Nice. Resting or resetting? Testing. None of the above. Gotcha. Fair enough. Do you do any? I mean, it's fine. It is pretty late. My grandmother's sleeping in the other room, so I feel you. It is understandable. Cool. Yeah. So we have basically what I'm trying to do is edge detection, specifically concurrency. Participated in hallucination. Oh, hackathon. Nice. Super sweet, super dope, awesome. That's super exciting, that's really cool. So, I'm trying to, like, I've solved this side of things quite easily. This was practically trivial. This took, like, the walls. Nice. Yeah, so, detecting the corners of the walls, the concurrency rules for the walls was like 4 lines of code. It's like super easy, barely an inconvenience. So now I'm trying to do the same thing for the floor, because I have some ideas for the floor that I want to do. I can do, yeah, because I can do some really cool stuff with I can do a lot of really cool stuff with the brick. Thanks. Yeah. This is actually technically a remake of a game that I made in 2022. You know, so like over 4 years ago. Well, almost 4 years ago. Because I made it in October. Yeah. Sadly, I can't really showcase the original build. It's only for Windows, and it runs like shit. It's actually linked in the description of my channel, QRN, on pitch.io. That's the game that I'm remaking. The original, the very first build is written in C#. Took me about 2 weeks to make. Runs like dog shit. I was setting every pixel to like a bitmap on like a JPEG, and then displaying that every frame in a WPF, C# application, which is not. I don't recommend it. If you care about performance, I don't recommend. Then I did an OpenTK version, kind of. I was like messing around with something in there, and then that didn't work out too well because my hash algorithm was dog shit. And so then I remade it in C++ with OpenGL, and that runs very smoothly. Yeah, I mean, I've been a Linux user since like 2010, 2011, right? As like a side, like I've always had access to Linux and used Linux to some extent. It's just that I had been using Windows as my main driver, as my main PC, because at the time, the development scene for Linux was not good. But in today's day and age, developing on Linux is arguably way better than developing on Windows. And with a lot of the really, really dumb shit that Microsoft is doing, I'm not gonna be on Windows. Fuck that shit. I'm not doing it. Yeah. So yeah. So basically, what I'm trying to do is, yeah. So for this project, yeah, and this is all in Lua. It's really easy to make cross-platform projects in Lua, especially like Love 2D. Because all you have to do is just make a zip file and then just cap the zip onto the end of the executable and then just release that, and it works fine. Right. So making cross-platform things is really nice. Also, developing in Lua is really, really, really. It's just super nice. It's the better It's the better version of it. It's just the better Python. Python is shit. I fucking hate Python. You know, so I don't like that white spaces are syntactically important. You know, indexing by spaces and tabs is like the worst possible idea ever. And when it comes to programming, I just want to punch whoever thought of that in the teeth. So yeah, so I'm currently trying to figure out how to do this concurrency detection, but for the ceiling and the floor. Okay. So, because I can detect if there's, like, I can detect edges very easily, but the floor, corners very easily, and that's all that you need for the walls, is just the, for the tile map, if there's, whose it was, it's, the only thing that you need to know is if there is it's easier to detect if there's a discontinuity, right? Or, like, you want to display if there's a discontinuity. And you just do that if there's a corner. And then one of the easiest ways to do that is if there is not a corner. And the ruling for that is like super interesting. Yeah, up here in isfill, it's literally this. It's 4 lines ago. Biff bang boom. Right? We just find the minimum. Yeah, we just find the minimum cell of the nearest corner. Oh, thank you for the follow. Arigato gozaimasu. So yeah. So here, yeah, we just find the minimum cell of the corner, and then if we get the major diagonal, the anti-major diagonal, we get the sum of the major diagonal and the anti-major diagonal, and then we just return if those are equal, and it works. It works really, really, really easily. It's super cool. Yeah. This is also a digital, it's also raycast rendering. Like, this is a 2D game. Like, this is technically 2-dimensional. Right? Yeah. So, yeah, this is all just a tile map. It's all just a tile map. There's just only one quad. You know, so I'm not, like, doing any projection matrices or anything weird or crazy like that. No, like, this whole thing is very lean. It is super lean. You know, like my computer is oh, I mean, if you want to know some information about my PC, it's old. It is very old. It's from 2010. It was constructed late 2010, so she's still trucking though. The stickers finally peeled off. Finally, like the glue, the adhesive finally gave out, and the stickers like slid off. I still have the Core i5 sticker on though. That one's on there. The Windows 7 sticker is gone, and the laptop info peeled off, slept off. Yeah, but she's still trucking. She's still going. I'm impressed. So yeah, we have the edge disc. The is fill, like this is so good. This is so good. Like this is such a simplified thing. Yeah. So here we have the top, we have the bottom, we have the left, we have the right. RGT. 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 That looks like it's gonna be better. Yeah. So we have the wall distance, which is either going to be 1 or it is minimum. We're going to be doing a bunch of minimums, which means it is the maximum. Which means those are the maximums of this, and nonde. No. Right? Well, we're going to be doing a bunch of minimums. So the normal is it not being there is going to be it not being there. Yeah, the minimum of the 1.0 maximum of this, and then we want the maximum of the cell and bada. And then we do a minimum of C00, C11, C. Well, let's find out what happens if we just do a min. If we do a min of the C00, C10, minimum of the C10, C11. Alright. Let's just see what happens if we do this one. We get this, which is Interesting. What did I fuck up? Ah, that's what I fucked up. That's not what I want. So it should be the so, yeah. So all these are gonna be doing now. Which is fine. That is basically saying, yeah, okay. And then I think it's just maximum of, yeah, so this is min plus I got 2, 0, 0. Oh. And then here. And so I got 2, 0, 1. I know there's probably way better ways of doing things, but right. And with any luck, this should just work. Does the complete and utter fucking opposite. Interesting. Monday. Detecting lots of weird shit. See, that is fine. This is not. So it's having issues with the corners. And it's also like okay. Alright. Like, the hell is up with this? Like, why? Does nothing. Um, I feel like I'm gonna have to do something else about this. What is the way? Hmm. What is the way? What is the way? Because there is a lot of dealing with What? Why is this one? So we are seeing a detection. It's just the wrong detection. Right? Because like we're seeing like these guys. Because we actually want if it's not there to be. If we want to see if it's not there to be one. Minus. I think this is gonna get us closer. It does. However, there's still a little bit of weirdness here. Alright. I think none. Why? What? Huh? The hell? Okay. So if we have no, actually let's do a different. This is a really shitty drawing, but whatever, right? So if we have I don't know, something here, right? Let's do good asymmetric, right? Do something like that. Right. So say there is one here, right? What we should see is something like this. because we would want something like that, right? Now, if it's there, we want to, and that is, so the diagonal, if the diagonal, so on the diagonal is the maximum. Oh, that's why it's not fucking working. Because I don't have a good way of slicing. Because I want to do this. I want to do this divot. There is something on that. I want to do, because it doesn't really matter. If I do the same, because if that's there, then this goes all the way up. And those are cut. Because that goes there, right? Adjacent is minimum. So how do we do this flip? Because we do because like the main problem is we don't know what's selling, right? We don't necessarily know what's selling. I mean, we do. I don't know if there's a way to there is an elegant solution. But I do not currently have it. Because the difference is that the corners. The corners. The corners. The corners. Because all I really have is corners, right? It's just one of the ones that I'm currently in is just like that thing. So I don't know. Because I don't feel like there's a way to explicitly figure out what corner. Like there is theory, but I don't know how to do that cleanly. Right? I want to do it. I like doing shit cleanly. I don't know. Right? Like I just don't know. There's gotta be a thing. There's gotta be something involved, right? And there is a pathway forward. And I think it has something to do with we take a look at this, right? We take a look at this, right? And then we have this, right? We know that if this is a 0, then it is extended out into here. But it is like dipped, right? Because if you are in this square, then it is just right. If you're in this square, right? You're in this region. This contributes both it is the maximum between the distance between the right and the bottom. The maximum. Okay. if it is adjacent. How do I do this? It's like the whole point here is that I have how? Because when it is directly adjacent, how do I find the adjacency? If I don't know what cell I'm in, because I shouldn't have to know exactly what cell I'm in. Right. I just know that I'm somewhere within here. And because of that, I need to know information about things. Because I will be, I'm somewhere within here. And then each of these gives some some contribution. Each of these regions will give some contribution. Right? How do I bleed into that? How do I bleed into that? Oh, hold on. What if I find the nearest point to that cell? Huh? Because that's this. And then if I find the nearest point by clamping, I clamp the UV to be the UV plus, so P is equal to cell plus UV, right? N is equal to clamp N, if this is target, right? E T plus 1. We can do that. And then it is the maximum. because is the max right, we have diff. Right, we have diff. We have delta is equal to p minus n, and then let's just call this d. P minus n, and then the t, well, the val is equal to the maximum of dx dy, right? And we just take the minimum of val 0, 3. We just do that. I think this is it. Right. Equals cell plus UV and equals clamp and T plus 1. Right. And it's just D equals P minus N. It's the maximum of those two. And then we take the minimum of all of those. Why is my CPU so? OBS, it's taking that long. I'm not recording. That's probably the audio bullcrap doing a robot. I mean, I'm only at 71%, so I'm okay with that. I'm very toasty though. I feel like I might need to start icing my computer. Because it's really fucking hot. Maybe a little bit more airflow might work. Right now, it's really fucking hot. It is toasty. I'll need to figure something out, but okay. So I do want the minimum of all that. Let's just do a return one for now. So I have an insert. We have that. Then we have the vec2 n is equal to clamp. But we don't do that, right? Because we need the t. Right. Because t is the current cell. So 4 and x. X equals 0, x. Well. Tx equals inside of x. So dot plus E n is p weak. Okay. Good, nothing. Nada. So Nada. Nothing. Das ist gut. 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 Denk das. Denk das. Ja. Das ist ja. Ja. Denke das. Denke das. Okay. Das ist gut. Weg to D is equal to E minus N. Float val is equal to max of d dot x, d dot y. And this is cell of 1.0 minus yes. I think T, right? T. Okay, good. No syntax errors. That's good. And then for each of those, because what we can do is we can say val is equal to minimum val comma and then here we nothing. Porque nonde. 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 Why are you so fucking hot, dog? Why are you burning up so bad? Why are you so hot, dude? What is you doing? Okay. The minimum of Val. It should be the minimum of. The maximum idea. It is the absolute value of it. And it's still not working. Monday. Okay. It's not gonna work though. And so y plus 1. Let's do it. Nande. Nande. Okay. Dios mío. Hold up. This is a little bit more as expected. It is detecting things kind of accurately. Look at that. Look at that. It is detecting this outside corner properly. And then, so some things are kind of. Is it t plus 1? Or is it t the bounds of right? So, when is that acting weird? So, nande. And not only that, that is feathering up. And this outer corner is correct. This inner corner is not. It like is trying to be. So what? None day, no. So that is in the because the square that it is currently in. Okay. Because of the square that it is in. So if so what about the square that it is in? It should be 0. Right? The maximum of that is going to be 0. Regardless, because of the cell that it is. But if that's the case, then okay. This is acting very stupid. But so there is something incorrect about my assumption. Something about my understanding of how this works is false. Factually incorrect. So it is not detecting anything on the higher side. It's only detecting the lower side. Why? I could unroll it, right? Like, I could unroll these things. Instead of trying to get fancy. Because in here... Because I do have something similar. Up in... here. Then... so. It's literally just those four. Do I want to do all the clamping bullshit? So... there's gotta be something else going on, right? Because trying to find... Okay. So... hold on. Number. Fucking hell, dude. What is it? What can it possibly fucking be? We have 4 things. Okay. That such a colossal pain in the ass, dude. I'm not entirely sure if I'm even getting. You know what? Yeah, that's true. I don't know what I'm getting. Not correct. Almost correct, but not correct. So, if okay, why is it not correct? Okay, so min cell. I feel like min cell is incorrect. I feel like min cell is problematic. Hmm. Okay. So there's something else going on here. There's something we're doing wrong. Not so. still doing that. $94, that's super posted. Put it on. Not very much airflow. It smells really bad too. If this thing fucking dies on me, I'm gonna be very upset. So, let's see here. So we are still getting okay. Let's do so if I'm gonna be doing this. Okay. Cool. Okay, so if I want to be doing this, then I want to get so. None. Nani? Random. Okay, so it is only on one side. Okay. And this is all only in one direction. And it is heavy. And that's so. That's so. Be only on that side. Okay. Gucci, Gucci, Gucci again. Okay. Or int tx equals mini south tx less than x x tx plus plus yeah. Int ty mini south dot y mini south less than x ty less than max south dot y ty well max well so tx ty. None. None. Why are you only doing that? Right. So it adds one and then it is no longer and then it ends. Not strictly less than, it's less than or equal to. Which then means I can Mm-hmm. That's just so we do have the edge detection. Now, it's actually fucking doing what it's supposed to do. Let's do the smart thing. So so back to B is equal to N for nearest is that key, and then I think T. T plus 1, I believe. Actually, what about 2D, the absolute value of one, val, so close. Oh. It is equal to that. So, yeah. So we can do H. Oh, okay. So it is this. And it is, so if it is 0, we return 1. If there is nothing there, right? Because it's the moment that, yeah. And the D is, I think it's what? So if it's 0, if there's nothing there, then we don't do anything about it. If it is the current cell that we are in, we have a problem. Right. So we only want that. We only want that this time. If is that. So if it is open, okay, then what we want the absolute value of the whatever that is minus the absolute value of that. Right. Possibly, I think, maybe. Maybe we can do the absolute value. That all t minus that. I think it's something along these lines. Because I need to mask it out. So for one, the current cell that it is currently in will always equate to 0. It's just going to be 0. So we don't want that. All open ones give one. One minus the maximum of whatever that is, 1 minus 2. So it would be the maximum of 1.0 minus. So hopefully, ooh, and that is perfect. And then multiply it. Perfect. So we have fully escalated all of that, and to prove a point, we can then multiply the edge distance all the way out. So even the wall distance is actually, even the wall distance is because now we have the full edge deflection. Very akin to ambient occlusion. So with that algorithm, but like this is full connectivity, right? We just didn't have to do anything quite as complicated with the walls because the walls don't have vertical differentials like the like the floor does. Now, if we were to have like half blocks up here, or if it was like 3 tall and had one up top to lower, lower cut down, right? Then there might be an argument for having a more complicated wall connectivity detection, but for all intents and purposes, this is, we have full, texture connectivity here, right? So I feel like, well, I'm gonna be going for it. Right. I'm gonna be going big. Like maybe in like half hour or so, something like that. I want to love more. That cold brew is definitely putting in work. I mean, I feel like the best way of doing it is to put it in a vacuum chamber. Pull out all the air from the grounds. And when you let all the air back in, it suck up all the water. And give it a good extract. I would really love some Everclear because Everclear would be wonders. Do extract all the caffeine and all that stuff. Literally make an extract. Then I can get what's faded. Woo! But for those of you who don't want to deal with alcohol, then use water. So it turns out I was just a uber fucking dumb fuck. So what is new? Oh right, fucking duh. Tattoo, you're a fucking dumb fuck. God damn, dumbass. Fucking uber dumb over here. Uber dumb. Uber Stupenhausen. So yeah, we have full edge detection because go fuck yourself. And again, this is pretty small. Like it's only like this whole thing is only 24 lines long. 24, 23, 22. I mean, it's only like 22 lines long. And that's with spaces. So, like, it's fun. And all of it is just understanding that you will end up doing a bunch of calculations overhead, doing a lot of extra calculations. And this is just super generic, so that we can do here. Yeah, we do the wall dist. Yeah. Because like this is ridiculously, you know, simple. Corner. Because then we could also do a times 16. Oh. And there you go. Super clean. Like, to the point that we can go up to the floor. Look at that. Fully connected floor. And it looks fine. It looks great. Looks very crisp. Yeah, looks very clean. Is what we are going to end up doing is to prove a point to showcase what the kinds of thing that we're going to do is we'll do a fract tan x times some number, and then we'll do that again. So the floor texture is, yeah. So let's do nothing's changed. Good. So, step 1. I want to say that val is equal to uv.x minus uv.y. Yeah. Then we could do then we can say val is equal to the absolute value of val. And then we get this. Very, very nice. Val minus equals 0. So all of these are switched. And then is equal to the absolute. Okay. Val times equals 2. You see how it's so fucking good. Oh my god, it looks so fucking good. I mean, it's so goddamn crisp. It's so nice. Oh my god, it looks so fucking good. Look at that. Look at that. Look at it. Look at it. Look. Look at that. Look at that. I mean, look at that. Look at it. It's so goddamn good. So good. Looks so good. Looks so good. So fucking good. That shit is fucking incredible. I do like the top line and shit. Like, I love it so much. I love it so much. I just fucking love it so damn much. Do I look like I know what a JPEG is? All I want is a picture. All I want to get is a have a picture of a goddamn hot dog. There's a picture of a goddamn hot dog. What's my name sometimes? Do I look like I know what a JPEG is? All I want is a picture of a goddamn hot dog. Yeah. So this is the thing. Which is but like this is also like, do I care that? Like, do I want that? Do I want, you know, these wizards and the other things? So I can also like change a lot of these attributes. I'm gonna do it like this way because like that just looks theatrical, right? I'm sure there's other like texture types that would probably look better. But I'm not like super sure. Cause I could do harsh. I could do harsh lines. I could do harsh lines on the brick. Right? I like the chamfers though. I like the chamfers. I like the bump mappy stuff. So there's that. I could also do some fun things with the offsets and other stuff, right? But yeah, connected textures look great. Fractional component, UV, and I did leave, right? So I could do that. And then, ooh, look at that. That's a lot more robust. Hey. Let's see here, right? So these are all a lot more things, but like this looks like it's really chaotic. What do you do when it's like this? Chaotic. Wow. I'm glad you asked. So the floor texture. We take in a vector. What if you also check in that? So one of the things we could do here is we could do this. And then right before we do anything else, we do UV. UV is equal to nothing's gonna change except everything's gonna change. Because we have updated this. Oh, the get color. Where did it from? Floor text. We need so. Which also means that down here. Okay, nothing has changed. This is good. Yes. Perfect. Oh, right. Oh, that's even better. Oh, this is gonna be so fucking sexy. This is gonna look so good. This is gonna look so fucking good. This is gonna look incredible. This is gonna look great. I'm super stoked. This is actually gonna look pretty good. Grandma. So floor. These are really thin. So these are like really harsh. But that's okay. Yeah, that's fine. I mean, these are pretty harsh, but I'm okay with that. I'm okay with harsh. More patterns, right? Because there's no anti-aliasing. I'm not doing super sampling. Just and the way to do that is that you would render to an off-screen frame buffer and then downsample it. I think something like this would be better. So yeah. So we have all of these. And then the real fucking magic is going to happen. The real magic is going to happen. So, you want to see the crazy? You want to see the crazy? So UV float flip is equal to the fractional components of the tangent of times plus UV at all times some, you know, 7 some prime and this is flip plus equals dot x v y and then v equals v dot fuck nande shit. Okay, yes, let's. Oh. Yeah. Here's the bitrate distortion 9000. The thing that compression algorithms hate. Welcome. Welcome to the bitrate distortion 9000. I mean, I'm still at 2K kilobits per second. Yeah. It's probably doing pretty good. There's a little bit of like starvation and stuff like that. You know, it's not a good hash algorithm, but like it's fine. So the main thing is we want to do for I don't know. So that is what we expect. So this is flip. I mean, this is also flip. We also see the fun bits here, right? See the fun bits here. And also see them on the other parts too. So that's pretty neat. It's fairly chaotic. There's a little bit of, you know, there's a little bit of grouping here and there. Could do a little bit better by saying maintain points just average, you know. Alright. So this will help break up any patterns a little bit. Alright, because that'll break patterns. There's still a little bit of looping, but not outside of like the ordinary. Right. There's like a little bit of patterning, not too terrible. It's good enough, right? If we really wanted to, then we'd do phi, we'd do phi, and do one of them. Then we can do phi and phi again. Just because, right? Because it is a random number, and then we offset it by something that's, you know, chaotic, and then it becomes more chaotic, becomes disjointed, and disassociative. Which is fun. It's not like the greatest thing in the world. That it is going to make dealing with the the overall hash algorithm. Either one, a colossal pain in the ass, but we will deal with it. And then for this, we don't want. Oh, we're flipping that. We're not. We need to. Let's see. So here you are. Welcome. Welcome to the chaos. So that's gonna be it for this video. For this stream. I am super pleased with how everything is turning out. I mean, I have a procedurally generated texture. I have bricks. I have completely customizable, you know, eye height, ceiling height, all that stuff. I will be dealing with the depth fog situation at some point. I have connected textures. You know, it's very subtle, and it's like super subtle. Like it's really subtle, but it really helps sell the textures. Right? It really helps solidify the reality of the space that you're in. Simply because like just that whole thing is this doesn't need to be horrifically, you know, random. Like, this is fine. I'm okay with this being as open-ended as it is. So we could also do, what is it? We could also do this. This looks fun. I don't know how I feel about this one now. Seems a little too funky wonky, right? Because like these pluses get. I don't like that. Let's go back to 4. I think that looks. But I think that is the same width as everything else. It is not the same width as everything else. That is half the width as everything else. Interesting. Strange. It's like half the width of. It's like sharper in the bricks, but it looks like the same. Is that weird? Interesting. So what if I do something like this, right? Oh. Interesting. Oh. Very interesting. Because that is the same way. that is the same. At least it's like close to it. Oh, you know what it should be? It should be the square root of 2. It should be like 2 times the square root of 2. 2 times this, 2RT 2.0. Okay. Oh, no. Okay. 2. I want 2. Yeah, that is fun. So, the bricks are... It's like lined up with the bricks and stuff. If I did 8, then it's all lined up with the bricks. But, this is... I am okay with this. So, yeah. That's gonna be it for this video. I'm gonna go to bed. For this stream, for this video, this stream, this lovely little slice of time video. I will see all y'all in the morning. Hope you guys have an awesome day. Hope you guys learned something if you're watching this on YouTube. Maybe get some ideas flowing. Yeah. So maybe I'm gonna get out of OBS before my computer fucking catches on fire. That's gonna be it. Hope you enjoyed. Got a new follower today. 2 new followers today. Possibly. I can't really tell you. I've lost my... I could just check my metrics and stuff, but